Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen.
Welcome to the International Seminar Research Month 2022 University of Pembangunan Nasional Veteran Jawa Timur.
The theme of this seminar is about technology, industrial development, and global business.
Before we start, we would like to inform that this seminar is organized by the Institute for Research and Community Services.
Seminar is to disseminate all the best ideas pertaining to practice of research and community services, especially in the topic of technology, industrial development, and global business. That is going to be the theme of our today's seminar. Before we start, let us introduce ourselves first. My name is Aryo Bimo Utomo.
And my name is Rahmawati, who will be the master of ceremony for today's seminar.
For the next few hours, we will be covering some important and interesting agenda. For instance, first, we will be singing the national anthem of Indonesia and Mars Bela Negara, and then followed by the community report of the head of the event. Next, we will be watching the video from Director of Universitas Pembangunan Nasional Veteran Jawa Timur to open officially the seminar. And last but not least, we will be continuing by our main session, that is the keynote speech session that is going to be delivered by our two distinguished speakers.
Ladies and gentlemen, before we start, we would like to also welcome His Excellency Rektor of University Pembangunan Nasional Veteran Jawa Timur, Profesor Dr. Insinyur Ahmad Fauzi MMT IPU, His Excellency Dr. Insinyur Sukenda MSc as First Vice Rector, His Excellency Dr. Insinyur Munawar MT as Second Vice Rector, and His Excellency Insinyur Sutiono MT as Third Vice Rector. We would like also to welcome the Director of Institute for Research and Community Services, Dr. Insinyur Yeni Wuryandari MP, as well as the honorable colleagues, and also the Director of State Polytechnic Jember, Mr. Saiful Anwar, STP MP.
Also, among us, I would like to also welcome our dearest dean of the Faculty of Computer Science, Associate Professor Dr. Nikita Sari. Welcome to the stage. And also our dearest faculty deans and program coordinators, welcome to this seminar. Also, to all the participants that have joined us here, we will all wishing you a good day and an enjoyable conference. Also, I would like to welcome our distinguished keynote speakers. The first one is Professor Vetri Murugan Elumalai from University of Zululand, South Africa. Also, Professor Aisyah Abdul Jalil from University Technology, Malaysia. Moving on to the next session, in the next agenda, we would like to kindly invite everyone in this room to stand up for a while because we are about to sing the national anthem of Indonesia that is going to be directly followed by the singing of Mars Bela Negara. So everybody, could you please stand up? Thank you. Thank you. You may now be seated.
Ladies and gentlemen, after this, we'll be hearing the report from the committee. But before that, we would like to invite the Director of Institute for Research and Community Services, Dr. Insinyur Yeni Wuryandari MP, to go to the main stage.
Also, we would like to also welcome the head of this event, Mr. Agung Brastama Putra, to come to the main stage. Thank you.
Ladies and gentlemen, after this, we'll be hearing the report from the Head of Committee of ISRM 2022. In this occasion, will be delivered by Mr. Agung Brastama Putra. To Mr. Agung Brastama Putra, the time is yours.
Please everyone give a round of applause for the committee.
Assalamualaikum warahmatullahi wabarakatuh. Mohon izin Bapak Ibu pimpinan. Untuk UPN Veteran Jawa Timur, Prof. Dr. Ahmad Fauzi, MMT, All Vice Chancellor and Dean, Direktur LPPM and Staff, Dean Faculty of Computer Science, Director Polytechnic of Jember, all presenter and participant, good morning to all of you. It is such a great honor to be here in a good and health and happy. Welcome to the International Seminar of Research Month 2022. After 2 years of ISRM being online this year, I'm pleased that the ISRM 2022 can be held by the COVID-19 pandemic condition worldwide has significantly influenced the shift in the outer human life in all fields. Humans are also becoming more dependent on technological sophistication and for their activities. Nowadays, various innovation and technologies are present and support the growth of global industries and business. In the digital area, the development of information and communication technology is significant in implementing cross-industry collaboration. This collaboration has also become a trend for cooperation and various industry business sector to win or maintain the global market. Technology, industrial development, and global business are exhausting issues to be discussed for several perspectives and disciplines. This issue became the main theme of the International Seminar of Research Month this year. Nowadays, post-pandemic, in research and community service in various commercial and non-commercial sectors. The ISRM is an annual series of international seminar held by Research and Community Service Institute of Universitas Pembangunan Nasional Veteran Jawa Timur, Indonesia. Today, I'm very pleased to inform you that 306 abstract accepted by the committee, and we will welcome present and participant to join the main session with our four keynote speaker. Also, we provide a forum discussion panel with 7 sub-themes. I would like to give my gratitude to the Honorable our keynote speaker, Professor Dr. Ventri Elumalai from University of Zululand, Professor Dr. Aisyah Abdul Jalil from University Teknologi Malaysia, Miss Tranti Hu PhD from Kobe Women University of Japan. Miss Adi Astri Putri Purbantina PhD UPN Veteran Jawa Timur. Special thanks for the Director of LPPM, the committee, and all contributing staff who have made this conference possible. And the last, for all presenter and participant, thank you for much for your presence. May you enjoy the ISRM 2022. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you for the opening remarks, Mr. Agung. Next, moving on to the next session, we will be moving to the next agenda. That is the official opening and the welcoming speech from the Honorable Rector of Universitas Pembangunan Nasional Veteran Jawa Timur, Profesor Dr. Insinyur Ahmad Fauzi, MMT, IPU. However, he is now unavailable to attend directly the seminar, but instead we will be watching the pre-recorded welcoming video from him. So let's take some time to watch the video. Thank you. Is the video ready?
Good evening, Salam, Om Swastiastu, Salam Kebajikan. The Honorable Professor Dr. Vetri Murugan Elumai from University of Zululand, South Africa. The Honorable Professor Dr. Aisyah Abdul Jalil from University Teknologi Malaysia. The Honorable Ms. Tran Tai Hue, PhD from Kobe Women University, Japan. The Honorable Ms. Adi Asri Putri Purbantia, PhD, one of our lecturer from UPN Veteran Jawa Timur. Ladies and gentlemen, but above all, experienced expert, friend, and colleagues. It is a great honor from me to be in your midst today. Let us say our grace to Allah Subhanahu wa Ta'ala for guiding us and provide with happiness and health. So we are able to participate in this international seminar of Research Month 2022. I would like to personally welcome the speakers, presenters, educators, researchers, and invitees for joining in this special event today. I hope that even though you are here online, does not detract from the objective of our activities today. Hopefully, there will be a chance for you to visit us in Surabaya. We are proud but humble to let you know that UPN Veteran Jawa Timur consists of 7 faculties and 31 study programs, and have achieved excellent status from the National Accreditation Institution. Furthermore, there are 13 study programs at UPN Veteran Jawa Timur that have been recognized internationally for the Foundation of International Business Administration Accreditation, or FIBA. Ladies and gentlemen, the International Seminar of Research Month 2022 is an annual event held by the Research and Community Services of UPN Veteran Jawa Timur as one of the strategic to contribute in publishing our research and community service. Research in universities is expected to be able to increase the competition of the nation based on science and technology. This is in line with the national framework of Ministry of Education, Culture, Research, and Technology. With this in mind, the research scheme must be in line the research topic and themes, and must not be guided by the national interest nor the open research strategic plan only, but it must also think of the green, blue, and digital economy, as well as themes related to tourism and health. This day, the whole world is moving toward green economic awareness. That is not only because of the need for the renewable energy, But green economy is a global trend and become everyone concerned these days. Furthermore, Indonesia as a maritime country has enormous potential in the blue economy. This potential can be put to good use with research support. In the era of the Industrial Revolution 4.0, which is already heading toward 5.0, they must also think of the development of the digital economy. Efficiency in all aspects can be achieved by using digital technology properly. As a state defense university, UPN Veteran Jawa Timur has a commitment to support this through the use of proper technology. We therefore hope that this conference will advance the development of technology and push the boundaries of knowledge and innovation. Finally, I sincerely hope you will enjoy your days joining this program. I would also like to take this opportunity to express our gratitude to the keynote speaker that have come today, the Director of Research and Community Services Institution of UPN Veteran Jawa Timur, and all parties who have put their ideas and energy into the success of this conference. Thank you for your participation and contribution. I wish you every success in your deliberation. May Allah subhanahu wa ta'ala, the God Almighty, always provide His protection and guidance, so our activities can bring out excellent outcome. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
That speech by our dear rector, Professor Dr. Insinyur Ahmad Fauzi, MMT has officially opened this seminar for today.
Yeah, such a heartwarming welcoming speech to all of us. So, ladies and gentlemen, the next agenda is the main session from our prominent keynote speakers. In this occasion, we already have Professor Dr. Vetri Murugan Elumalai from South Africa, as well as Professor Dr. Aisyah Abdul Jalil from Malaysia. In this main session, will be moderated by Dr. Nur Aini Fauzia. To Dr. Nur Aini Fauzia, the time is yours.
And beforehand, we would like to also thank you, Dr. Yeni and Mas Agung, for coming to the stage. Thank you.
Thank you.
Oh, yeah.
Thank you very much for the MC for the time, and good morning. Assalamualaikum warahmatullahi wabarakatuh. Okay, good morning. Once again, maybe. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, good morning. Greet Nama budaya, salam Assalamualaikum, good morning. Okay, baik. The Honorable Rector of UPN Veteran Jawa Timur, the Honorable Head of Institution, Research and Community Service LPPM Veteran Jawa Timur, the Honorable Faculty Dean and Program Conductors in UPN Veteran Jawa Timur, the Honorable our keynote speaker, Professor Dr. Vetri Murugan Elumalai from South Africa, and also Professor Dr. Aisyah Abdul Jalil from UTM Malaysia. International Seminar Research Month 2022, and all of the audience in this seminar, which join by online and also join by offline. Okay, and also all right, in this session, I will guide for the main session. I'm Nur Aini Fauzia, I'm moderator in the session, and we will listen from the two keynote speakers, which come from Professor Elumalai. Okay, let's we greet the Professor Elumalai. Hello, Professor. Can you hear me?
Yes, I can hear you.
Okay, It's clear or not?
Yes, very clear. Perfect.
Okay, thank you, Professor. And also our second keynote speaker, Professor Dr. Aisyah Abdul Jalil. Can you hear me, Professor Aisyah?
Yes, Anjani, I can hear you.
Okay, how are you, Professor?
And thank you.
Okay, nice to meet
Nice
you
to
again,
meet you again.
Professor.
Yes. Nice to meet you again.
Okay, Professor. Okay,
Okay.
ladies and gentlemen, in this session, we will continue to the next agenda, and the second keynote speaker was ready on the virtual, and now we continue to the first keynote speakers, Professor Elumalai from South Africa. Before we continue to the presentation, let me to introduce Professor Elumalai from South Africa. Professor Elumalai was full professor in Department of Hydrology, University of Zululand, South Africa. His experience are on environmental hydrogeochemistry, groundwater environmental pollution, and many more. Without waiting any longer, we uh, please welcome to Professor Elumalai from South Africa. Professor, are you ready for presentation?
Yes, I'm ready.
Okay, time is yours, Professor.
Thank you so much.
Professor, sorry, we can't to see your screen. Maybe you can open your camera.
Can you able to
Yeah,
see now?
okay. Yes. Okay, please. Time is yours, Professor.
Okay, thank you so much. Thanks for your welcome address. Dear colleagues, good morning to everyone, in particularly chair of these sessions. Sorry, I can't mention their name, each and everyone. Also, warm greetings from South Africa to everyone. Yes, as mentioned in the introduction, my name is Professor Elumalai. I'm professor in the Zululand University. A couple of months ago, I was visited in your university. It was a wonderful experience which we had. I came with my Vice Chancellor and the Deputy Vice Chancellor. It was a great experience. We all enjoyed a lot. Also, we it's more interesting to learn about your university and in Indonesian cultures. Really, it is a very big thanks to the organizing committee like Zen, Indira, is they all highly supported throughout for our visit. Really, it was very interesting. Okay. Okay. Colleagues, today I think that my keynote's address is going to discuss our research experience in related to hydrogeology, in particularly water quality and management issues, what we conducted and published recently in the KwaZulu-Natal coast, in particularly northern part of the KwaZulu-Natal coast, which is located in the nearby the Durban. So the title of this topic is to determine the
Sorry,
health
Professor.
risk. Yes,
Hello.
can you hear me?
Maybe can you open your camera?
You can't see me?
Can you open your camera so we can to know about your face, maybe?
Oh, sorry. I thought it was
Yeah.
open.
Okay.
Sorry.
It's very fine. Okay, Professor. Thank you very much.
Okay, it's pleasure. Sorry. I hope my slides is clear. I'm right. Can you able to see me now?
Yes,
Yes.
Professor.
Okay, thank you. So this is at okay. The title is determining the health risk associated with groundwater contamination and management of coastal aquifers in South Africa. So, colleagues, the South Africa is water scarce countries. Is particularly the potable water is highly demanded due to the limited water resources and unpredictable conditions, because in South Africa is a developing country. It's a rapid development of the urbanizations and the expansion of the agricultural land and the climate change. These all lead to the increase the demand of the potable water resources. That's why most of the provinces in South Africa is the 9 provinces it's called. It's in the coastal area, in the four or five provinces, mostly they rely on the surface waters, in particular in the northern part and Limpopo for provinces, they're highly depending on the groundwaters. Okay, so the climate change is unpredictable condition in South Africa. Also, the industrialization also is increasing. So, due to these reasons, the groundwater resources is under pressure conditions right now. So about 52 percentage, around 49 million of the South African populations is still living in the rural area based on the Department of Water Affairs statements. Almost is 70 percentage of the population still living in the rural areas. So total population is around 60 million peoples. So from that, it's a 6 million peoples do not have the proper access for drinking waters. In particular, those who are living in the rural communities. Okay. So in this research of the Maputo land formations, it is located in the coastal area of the KwaZulu-Natal. It is one of the popular tourist places in the KZN provinces. Okay, so in these particular areas, the groundwater is the major source for drinking and irrigation purposes. Okay, so the people, they are abstracting the groundwater through the borehole from unconsolidated formations. That is that the area, the aquifer condition is it's unconfined aquifer. So the rate of infiltration is higher compared with the other places particularly in the inland area. So when the infiltration is taking place more, the pollutions also, the contaminations, solutes also is moving rapidly. Okay. So this Maputland coastal plain is a completely alluvium formations. So which are more prone for surface contamination, further resulting in the degradation of underlying aquifers. So as I mentioned before, it's more than 400 rural communities still they're depending on the groundwater resources for domestic purposes. So Department of Water Affairs reported in 2018 is mostly in the domestic, the groundwater is contaminated is by the domestic disposal, fertilizer using in the agricultural lands. Also the effluent from the industrial sites is had led to increasing the salinity and the contamination of the groundwater with high ionic concentrations, in particularly heavy metals, microbiological aspects, the pollution is taking place. So the Department of Water Affairs and the Department of Water and Sanitations advised and suggested, so it is very important to quantify the origin and the sources of the pollutions, also the measure the possible mitigations to supply the safe drinking water to the rural communities. So here you can see here the rainfall of the South Africa. Okay, so you can see here where the blue highlighted here This is where we are located here, where I'm living here. Our research area also is located here. You can see in the western part, northern part and western part of the area is look like a deserts, because in South Africa average rainfall is 400 millimeter per year. Okay, if it is compared with the world average, it's a for 870 millimeter per year, but the difference is 420 millimeters. So it is a big differences. That's why the South Africa is, we are called the water scarce country, one of the water scarce country. But I know, I think I went through some articles in Indonesia. I think the Indonesia, the annual, in particular the Jakarta, the annual rainfall is more than 1,700 millimeter per annum. But here you can see here, we are receiving is less than 450 millimeter per year. In particularly here in the coastal area where the blue colors are located, this is the highest rainfall we received from the country. So here in the coastal area, in particular in the KwaZulu-Natal coast, receive highest rainfall is average around 1,100 to 1,200 millimeter per year. So rest of the area, in particular the Western Cape area, is less than say 400 millimeters per annum. In the middle of the area is Limpopo province and Gauteng provinces. We received say 850 millimeter per year. So these agricultural activities in South Africa, as I mentioned before, the 9 provinces. Okay, from the 9 provinces, in particular in the KwaZulu Natal is mostly in the timber and maize formations, and the sugarcane is more dominant here. In the Limpopo and the Mpumalanga, there are a lot of vegetables, also the maize they are cultivated. But in particular, the northwest provinces and northern provinces is completely the cattle field. Livestock, the agriculture is taking place. In the Western Cape area is a lot of wine farms we can see in this area. So it's one of the best place for wine industries in South Africa is the Western Cape, particularly in the Cape Town areas. So South Africa, you can see this picture is ranked as the 30th driest country in the world. But if I compare with South Africa and Indonesia, definitely you are far better better than us, better than South Africa. See here, recently in South Africa, the climate change is playing the major role to improve the water scarcities. So it's unpredicted and also unprecedented extreme events we got experience in 2018 in the Cape Towns. I hope you all know the Cape Town is one of the biggest metropolitan cities in the country. So 2018, the government, they announced day zero. The day zero means there is no water to supply for the communities. Okay, so the day zero is set occur when water level in supplying dams fall to 13.5% of the capacity. So all the dams, at least minimum 20% should be maintained the capacity, because not only for the human beings, other ecological aspect, it is mandatory to maintain at least minimum 20%. So since 2014 until 2018, the rainfall intensity slowly decreases. That's why all the dams, they can't able to fill the waters. So in that cases, water level slowly decreases. So average rainfall in the Eastern Cape less than 450 to 600 millimeter per year. But last 3-4 years since 2014, the rainfall intensity gradually decreases less than 400. That's why the water scarcity issue was taking place. You can see this picture is this Three Waters Kloof Dam when it was the fully storage of the water, but when it's dried in 2018, it's completely dried. So during the day zero announcement, the government they strictly bring the rules and regulations, but they allowed to use 50 liter of the water for the communities. Also, there is no water supply directly to the households. So the people, the common place is there. The people go and get a water from. So so many rules are bringing. So you can see here the drop of rainfalls from 780 to 325 millimeters. Further, it goes 221 millimeter. Then it is a 157 millimeter. I think the Jakarta is received the average monthly rainfall is more than 250 millimeters. You can see compared with that monthly rainfall, the whole years in Cape Town cities in Western Cape provinces less than 221 millimeters. That's why the water scarcity was increased during those periods. Okay. So here what is the interesting things currently due to the uncertain climate change? It's playing a major roles. The one side is a severe drought, another side is another places is floodings. But examples of here when the South Africa is getting the severe drought during that periods, you can near neighboring countries like Mozambique. See, it's a big cyclone. Cyclone was hit during the 2021 January. Okay. So almost more than 600,000 people they lost their homes. But in same time, the beginning of this year in South Africa, one place is the heavier drought in particularly Western Cape and Eastern Cape provinces. But beginning of this year in KwaZulu-Natal provinces during the April 2022, the heavy floods almost 400 more than 400 people they dead. 6,000 people they lost their houses. Almost more than 4 months it's taking to recover all the bridges and the construction of the new bridges. Still, it's not getting back to normal in the KwaZulu-Natal provinces. So this is the issues what we are facing in South Africa currently. You can see these pictures is clearly explain the Western Cape drought situations since 1920 until 2018. So this drought it happened as per the data is once in 400 years. So that's why it's a severe effect of the Western Cape provinces. The government now it's trying to bring it to so many recovery plans like sewage treatment plant the increasing, also the desalination plants the increasing to bring out the recovery of the because it's almost 20% of the population is living in overall the country living in the Western Cape because Western Cape is one of the biggest provinces, also important place for the tourists. So that's why the immediate recovery is mandatory for these areas. So the government they're planning to bring back to the normal position as soon as. So another things in South Africa due to above issues, the water scarcity issues, the irrigation plans is completely different compared with the Asian countries because Asian countries is they have the heavy rainfalls. Also, they had the enough water for two irrigations. Okay, so but in South Africa, it's not like that. So that's why we have the very less rainfall due to this less rainfall event. So most of the agricultural practices they're using for the spray irrigation or drip irrigation methods they're using. Also, each and every agricultural farms they have their farm own dams. It's called the farmer dams. So what they will do, they store the rainwater in the dam. So throughout the year, they are using for the agricultural purpose. This one. So here, each and every farms at least minimum 100 hectares to thousands of hectares land they're cultivating. So it's not easy for the canal irrigations in South Africa. Also, in particular, you can see here in the pictures where the storage tank here, this picture is from the Limpopo, also the Free States provinces. Okay, here what they will do, the people they rely on the groundwater for the irrigations purposes. So what they will do, but the capacity of the yield of the groundwater is very less. That's why they build the storage tank. They store, they build, they can drill the boreholes in the different places. Then they can store the water from the borehole. Then they can use for the irrigation purposes. Now coming to the subjects. Okay, so this is objectives from our research what we done so far. So the objective one is to understand the aquifer characteristics and the geochemical process in coastal aquifer. The second objective is water quality characterization and identification of sources of pollutions in Maputland Plain. The third one is to assess the potential human health risk assessment due to contamination in the different age groups. Okay. The fourth one objective is to identification of the delineation of groundwater recharge. So the last objective is to develop development of groundwater flow and solid transport model to understand the long-term variation and prediction for sustainable management of groundwaters. So this is a study area map which I shown here. So you can see here the study area is it's called the Maputland. The Sodona Bay is the major important town. This is a rural town in that area. So this area is located from the Durban approximately 200 kilometers far away from the Durban. Okay. So the total area of the study area is covered 2,200 square kilometers. The rainfall is 1,100 millimeter per year. The temperature is it's varying, depends on the winter and summers. Some winter is 16 degree, the minimum, maximum. In the summer is minimum 27. It goes up to 40 degrees sometimes. Okay, so the geologically this area is completely unconsolidated formations, and then in the two partially consolidated sediments. When it goes to in the bottom layers, the consolidated sediments, because it's depends on the age. Okay, so the main agricultural activities of this area is commercial forest, and sugarcane. Then the maize and pineapples, citrus fruits, lychees, some bananas, some other vegetables. Also, some rural communities they are doing the micro cultivations of the so many vegetables in these areas. Okay, so geologically, these are the quarterly deposits. It's unconfined aquifers. So we collected the groundwater samples during the 2018 and 2019, around 51 boreholes. We analyzed for all the major, minor, and trace metals. Okay, for the identification of the recharge zone, we used for the GIS and some satellite data. We used for the developing the groundwater modeling. We used for the FEFlow groundwater softwares. Okay, you can see here this is a piezometric map of the study area. We consider it is the below ground levels. Okay, so here the piezometric head is a 5 to 10 in the area, different area. Then this is different, depends on the colors. Okay, you can see here in the southern part of the study area, it's about 15 meters. Then, so the maximum groundwater level is increased up to 25 meter below the ground levels. Okay, but in particularly in the high water level in the north and eastern and some central part of the areas is a high water level. Okay, so lower water table is it's distributed in some central part of the study area. Okay, so the process controlling the water quality, the geochemical process, what happened in the study area. You can see here this we compare with the pH and EH. Okay, so based on that is most of the samples is falling under the as a acidic reducing area, the few samples falling under the oxidizing zones. Okay. Then, so also we compared with the rainwater and seawaters. Okay, so here about 53% of the samples of the study area have pH values is the less than 6 to between the 6 to 6.5. The pH values is the 6.5 to 8.5 is the standard values. Okay, so the relationship of this EH and pH in the established to order to the environment. Okay, so also we collected the compare with the seawater and rainwater samples to understand the benchmarking the water environment. Okay, so the seawater pH is 8 and EH is 6. The rainwater pH is 6.5 with the EH of 5. Okay, so majority of the samples here as per this picture is fall under the neutral to acidic conditions. Then again we try to understand the dissolution and the precipitation process using various saturation indices. Okay, so the saturation indices is it's with the respect of the minerals dissolution in the its nature. Okay, so if the water, if it is undersaturated, then we can understand it's a process controlling the dissolutions in the study area. If it is oversaturated, the precipitation is taking place in the predominant in the area. So how we are calculating the saturation indices based on the values. Okay, if it is less than 0, the groundwater is undersaturated. If it is more than 0, it indicates the oversaturated. Sometimes if it is equal to 0, it's an equilibrium with respect to the minerals. So as per this picture, you can see the saturation indices were calculated. It is in order to the calcite, gypsum, fluoride, dolomite and halite. Okay, you can see this picture here where it's a circled here. So in the sample number 1 and 6 shows the calcite and dolomite values is greater than the 0. Okay, whereas the remaining 51 sample shows the calcite, gypsum, fluoride, halite values, all the values are less than zeros. So the samples with saturation indices values is less than 0. It is clearly indicate the water is under saturated with the calcite, so dolomite, gypsum and fluoride. Okay, so the reason, the causes for this, it may be the removal of the carbonate minerals through dissolution. Then the rock weathering and precipitation and evaporations, we compare with the Gibbs plots. The Gibbs plots we use for the TDS, compare with the all the sodium, potassium by sodium plus potassium plus calcium. Okay, other side is the TDS with the chloride by chloride plus alkalinities. Okay, you can see this Gibbs diagram shows most of the samples is falling under the rock weathering dominance. Okay, so that means it confirmed that in this area, it clearly indicates this rock weathering is dominance of the areas. Okay. Then the ion exchange process. Okay. So various plots, the bivariate plots we used to understand the ion exchange process. So also this relationship with the major ions with the different parameters we used. Okay, so wherever the relationship it shows strong linear relationship of the more than the R square value more than 9, it's a strongly confirm the process. You can see here the negative correlations which indicates a cation exchange of calcium and magnesium for the sodiums here. Okay, so if the calcium plus magnesium bicarbonate sulfate and sodium chloride ratio, if it is close to the -1 dissolution of calcite, dolomite, gypsum, etc. If it is less than 0, then the calcium or magnesium is exchanged by the sodium. if the sodium chloride values is less than 0, the sodium is exchanged by the calcium or magnesium. So the groundwater samples of the study area shows the less than -1 ratio, which is clearly indicates the cation exchange of calcium and magnesium for sodium in groundwater. You can see the another hand. Here the sodium versus chlorides. This is clearly indicates the excess of chloride was balanced by the calcium and magnesium. Okay. So the TDS versus major ions here, in particularly the bicarbonate, chloride, and sulfate, it's clearly indicate the increasing in sulfate, bicarbonate, chloride concentration with increasing of the TDS. Okay, so the sodium chloride forms mainly component of the halite, calcium sulfate formed in the main component of the gypsums. So the calcium chloride sodium concentration of the groundwater is relatively higher, and therefore it would be dissolution of evaporation. This is a geochemical process. In fact, this is a Piper diagram shows is mostly in the water types is a sodium chloride. All the samples, most of the samples fall both years falling under the sodium chloride water types. So here you can see here the CaA2 and CaA1 diagrams, which is so most of the samples is falling in the reverse ion exchange process, the few samples falling under the ion exchanges. Okay, so this is clearly indicates in the reverse ion exchange is dominant than the ion exchange process. Okay, so also here we plotted with the magnesium by sodium with the calcium by sodium. Okay, so here is a silicate weathering and is dominant, and evaporation solution dissolution is some dominance. Also, we compare with the bicarbonate and calcium by sodium also, the silicate weathering is dominant. So, in this particular area, so the silicate weathering and reverse ion exchange is the dominant process of the study area. Then we try to compare with the nitrate concentrations, because in this most of the air study area is agricultural areas. So what we be thinking is there any agricultural input for the increasing the nitrate concentration? We try to identify. So we compare with the nitrate concentration all the major ions. What we found here in particular areas for the both 2018 and 19 areas, the nitrate concentration mostly is less in except the few wells. Okay, so those wells we identified where the high input of the fertilizers in the agricultural area, we understand the concentration of the nitrate is increases up to more than 100 milligram per liters. But most of the areas is the less than permissible limit based on the WHO standard of 45 milligram per liter. Okay, so that means nitrate is derived from the agricultural activities. Then the water quality index and the assessment of water for drinking purpose we try to identify. You can see these pictures here. In the northern part and southern part of the area, it shows the unsuitable for drinking, which shows the white colors. Okay, so the most of the sample, around 67% of the sample, it shows the excellent for the water quality. About 22% of the samples belong to poor water qualities, and 2% of the samples is very poor, which is very poor for the water quality. So it shows that means only 7% of the sample it shows the unsuitable for drinking purpose. So the water quality index, it clearly shows the majority of the samples belongs to the good water quality types. Okay, except the few samples which is located in the southern and the northern part of the area. Then we try to understand the heavy metal contaminations. We used various different, almost more than 10 metal contents to study in this area. So the pH is varying the 5.3 to 8.3 is the average value 7.1. Okay, so the electrical conductivity of the study area is a minimum is 150, maximum is 1194 with the average of 330. Okay, so the cadmium is a 23 percentage. For the cadmium, 23 percentage of the sample exceed the based on the South African standard. The iron is about 11% of the samples is exceeded the beyond the limits. Lead is approximately 25 percentage. So here the iron, lead, cadmium were recognized the dominant heavy metals concentration in the study area based on the South African and WHO standards. Okay, you can see here the heavy metals concentration, spatial diagram of the heavy metal concentration. Okay, so in the high concentrations is mostly in the observed in the northwestern part and southeastern part of the area. Okay, in the iron content you can see the lead concentration is recorded in the southeastern part, also northern and central part, and southwestern part. The lead, the cadmium mostly we found in the southwestern and northern, and some places of the central part is the cadmium concentration is beyond the limit. Okay, so that means it's around 43 and 57% of the samples is classified based on the pH and metal loaded concentrations. It's a high metal and near neutral extreme metals. Okay, so the high acidic pattern plotted against the pH would be due to the wastewater discharge, also the agricultural activities input during the irrigation times. Then we try to understand the seawater mixing process with the various parameters. You can see here in the seawater mixing figure, this is a seawater mixing index for the 2018 and 2019. Okay, so it is clearly identified here. Seawater mixing is based on the 4 major ions: sodium, chloride, sulfate, and magnesium. Also, the indicator of the seawater mixing, the bromide also, bromide and lithium also one of the indicator, but unfortunately we couldn't measure the bromide, but we used only for the sodium chloride, sulfate and magnesium. So as per the seawater mixing index values, if it is greater 1, suggests the impact of seawater mixing with the fresh water. In the study area, the seawater mixing index is ranged from 0.3 to 2.4 during the 2018 and from 0.14 to 11 during the 2018. So almost 15% of the samples during the 2018 and 11% of the sample 2019, the groundwater sample has the seawater mixing, suggesting that influence of mixing with the saline waters. Okay, then we compare with the electrical conductivity with the chlorides. You can see here. So the electrical conductivity and the chloride, that also it indicates a majority of the samples fall under the seawater mixing zones, except the few samples. This all also confirming that seawater mixing is happening in the study area. You can see here the seawater intrusions zones. Most of the sample is fall here. Then the health risk assessment. So initially we studied the general geochemical process, then the water quality index parameter, then the heavy metal studies we finished. Now we discussed about the health risk assessment. So you can see this picture here. We used for the 2 different parameters in the hazard quad and hazard index. We calculated for the children, infant, and adults. Okay. So the health risk assessment, as per this picture, the cobalt, cadmium, arsenic, and manganese pose serious to adverse risk to the peoples. The HQ dermal and HA values of infant are higher than the children's and adults. It is clearly indicate the infants are more vulnerable than the children and adult. So the arsenic and cobalt for drinking water purpose for a longer period may cause potential and adverse carcinogenic effects, hypertension or skin problems. Also the neuropathy problems also is possible. So this is important for this study, which the infants are highly affecting. Then based on that, the spatial variation of the HQ and HA values for the infant, for the children's and adult, we studied for the another aspects. So you can see here the health risk assessment. Based on the trace metal contaminations in the groundwater, in particular children and adult, it is a trend decreasing from cobalt, lead, cadmium towards the nickel for both and children's and adult. See, the average HQ value suggests that the cobalt has shown the highest of the total non-carcinogenic health risk in the study region. See, the HA values for the certain elements is greater, suggesting non-carcinogenic health risk likewise. So in this study area in particularly, we discovered here 43% and 26% of the groundwater sample poses non-carcinogenic health risk in children and adult respectively. But here is mostly in the high percentage is located in the northern part and the southern part based on the HA children. For the HA adult also is the mostly northern part is the highly affected than the southern part. In some of places in the middle of the area is also highly affected. Then we're thinking to identify the groundwater recharge zone mapping to control the groundwater quality and management protocols. Okay. So what we did, we used for the GIS remote sensing techniques is advanced tool to understand the delineating potential groundwater zones. Okay. So the recharge zones were determined by the comparing the analytical hierarchy process and multi-criteria decision-making techniques, both Boolean logic techniques and Boolean logic approach we discussed based on the different geological conditions. Okay, so this is the classification of the weightage what we gave for the depends on the influence factors and the features area. Then the Boolean and AHP techniques which we used. So these all the parameter we used, all the geomorphology, geology, rainfall, these all the parameters. So all the factors are assigned weightage from 1 to 9 according to the scales. Okay, so the value 1 donates the very less importance between the thematic layer, and value 9 donates the very high importance of the thematic layer compared to another. So these are methods what we used. So all these thematic layers we used to predict the rainfall recharge zones. So each layers were assigned subject to weight 1 to 10 and 0 to 1 under the AHP and MCDM and Boolean approach based on the significance of the groundwater recharge. So this is the spatial distribution of the morphology, geomorphology, rainfall, linearment, slopes, also the drainage density, these ones. Okay, so you can see here in this area, the agricultural area, sugarcane cultivation is the major activities. Other than that is some vegetables, pineapples, and some citrus fruits. In particularly the commercial forest also is dominant in this area. You can see here, this is the geology of the area. Geology is mostly covered by the alluvium and arenate in the inland area, and towards the western part, the siltstone is there. Then some the rhyolite also, some small patches we can identify. This geomorphologically, this area is completely flat area. It's a undulating plains. Okay, the plain, because it is the coastal area. That's why there is not much elevation. But in this western part of the area, we can see moderately undulated plains. But here in the coastal area is a thick alluvium deposit. The dune deposits we can see here. It's around more than 100 meter height. So here, this is the land cover changes. It's in the mostly in the agricultural area in the northern and the eastern part. In the middle of the area is so also the cultivation is taking place. Okay, so based on all the parameters, we try to identify the zonation map based on the AHP-MC-DM techniques and Boolean maps. Okay, so you can see all the maps when we overlapping, then we identified. So as per the AHP-MC-DM techniques and the Boolean approach, it's about 73% and 70% of the area potential groundwater recharge. So this study, you can see here. So this study will helpful to sustainable management of groundwater pumping in the study area. So obtained results were further used for developing the groundwater modelings. Okay, so based on these maps, we try to develop the groundwater modeling to predict the groundwater flow and solid transport in the study area, in particularly in the agricultural area. So the groundwater modeling we developed in the due to the agricultural activity. You can see this picture. This area is intensively agricultural activities is taking place. We can see this is one of the biggest St. Lucia lakes here. Okay. So this area in the groundwater, based on the previous study, the groundwater is affected by the by the natural and anthropogenic activities. So in particularly sodium chloride concentration is high in the coastal areas due to the seawater intrusions. The nitrate concentration is more in the inland area, in particularly where the agricultural is dominant. Okay, so the coastal aquifer, as we mentioned, geologically it's a completely alluvium formation. That means high permeability sediments. So the pollutions is taking place. It's a rapid pollutions. Okay, so the infiltration is rapid. So pollution also is easy to migrate from one place to another place. So the finite element subsurface flow we use for the feed flow softwares. The model allows the analysis for both saturated and undersaturated aquifers conditions. Okay, so it can solve the advection dispersion equation of contaminant and heat in 2 and 3 dominant dimension it is. So these are model discretizations. Okay, so the total area is the 1,227 square kilometer. The elevation from 0.5 in the coastal areas, it's increasing towards the western part is up to 178 meters above mean sea level. So this is a coastal aquifer. The major source of the recharge of the groundwater is the rainfall is the major source. So the boundary condition we considered here, if you can see here the constant head boundary, because in the Indian Ocean is located in the eastern part. So the head is constant. That's why we consider as the constant head boundary. So here in the northern and the southern part, we consider the flex gate boundary because the water table is fluctuating based on the climatical condition we consider. But here in the hard rock region, it is in the western part of the area, in particularly southwest part of the area. So we consider this is the no flow boundaries. So we used the various geophysical parameters, also the pumping test and borehole lithological data to understand the subsurface characterization of the study area. So the study area is more dominant of the arenite and alluvium formations. The lithola cross sections we got it from the geophysical survey from the Department of Water and Water Affairs. So the resistivity methods we used, the around 13 locations of the study area where the vertical electrical soundings we carried out, then they used for the Schlumberger array. So these geophysical data we used to develop the groundwater. This is a modern conceptualizations. So the four layer we consider based on the lithologies, okay, and the cross section of the area and the geophysical survey. So the layer one, you can see here that mostly, as we mentioned before, the alluvium and arenite is the dominant. So the layer one is the 0 to 3 meters. Layer two is the 5 to 35 meters. Layer 3, 30 to 42 meters. Layer 4 is the 25 to 38 meters. So the maximum is the 45 meter we consider to develop this model. So this is the input parameters. Okay. So the input parameters we give the hydraulic conductivity based on the geological formations. The arenite is the 3 to 0.4 meter per day. The alluvium 5 to 2 meters. Then the porosity also is different here. This is the layer one, each layers. Okay, the layer one, layer two. So the field measurement parameters, the pumping test were utilized to assign the hydraulic conductivities and the porosities. Okay, so we got this data from the Department of Water and Sanitations during the 2000s. So we consider these data for the initial head. Okay. So you can see here this picture shows the conductivity. The conductivity is very less in the north southwestern part of the areas. In the conductivity is good in the where the alluvium domination areas. Okay, the porosity is very less in the northwest part of the areas. Same like the hydraulic head is vary. Hydraulic head is a maximum is a hydraulic head is in the coastal area is very deeper in some places of the inland area. Okay, this is the the hydraulic head is 2 to 8 meter below ground level in the unconfined aquifers. So then these all the input parameters which we gave here. Also we compared with our rainfall intensity for the 2000 until 2019. Okay, so the main rainfall is 20 to 25% of the rainfall is recharged into the aquifers for the total rainfall. Okay, so the groundwater recharge was assigned from actual daily rainfall data from 2000 to 2019 as time dependent. So the delineated groundwater recharge zones where we identify from the previous studies, it's assigned 20 to 25% of the recharge is possible in the sedimentary areas. You can see here the rainfall intensity since 2000 it shows more than 1200 millimeters, but after that it's gradually is decreasing until the 2007. So see, that means here we consider once in 4 years the drought in the study area. So we try to run the model in the steady state and transient state conditions. The simulation was carried out in the with the groundwater head of 2000 January as the initial head. Okay, so you can see here the groundwater head. This is observed groundwater head based on the data we collected from the department. Yes.
Excuse me, can you hear me? Okay, 5
Yes.
minutes left, maybe.
Sorry.
Okay, 5 minutes left. 5
5
minutes
minutes.
left.
Yes, I think I started 4:27. Yes, I'm calculating this.
Okay, Professor.
Yes, you said 1 hour time. Yes, another 10. I think 8 minutes more. Sorry. Okay, so we consider the groundwater head similar to groundwater level also. See, is perfectly our calibration is matching. So during the calibration, the K values and the porosity we slightly changed based on the geological formations. The same following that the transient state condition, the groundwater flow model also we correlated between the observed and calibrated. So this one also the groundwater perfectly is matched. The R square value is 0.98. Okay. So the groundwater flow vectors is moving towards the eastern part. The groundwater flow is moving towards the eastern part of the area, where towards the Indian Oceans. Okay. So the temporal variation in groundwater head we identified. So the predicted and predicted and then observed values, so simulated values. So you can see we three locations we calculated, we considered. The location 1, the water level is declining 3 meter. Then the location 2 is 4 meter, location 3. So these all the locations we consider in the different areas. One is from the coastal area, another one is agriculture area, third one is the inland areas. Okay. So then that means the same trend, if it is continuously happen, so the rapid declining of groundwater head after 2030, it's very drastic changes in the groundwater head. Then the solid transport modeling, we try to understand how the solids are moving, in particularly sodium chloride, nitrate we consider, because the sodium chloride is the seawater intrusion parameters, nitrate is the input from the agricultural activities. So we understand the long-term observed water quality data was utilized to predict the spatial and temporal variations. So up to we consider the groundwater modeling we run up to 2040s. Okay. So the solid concentrations of nitrate concentration we assigned, you can see here the nitrate concentrations, it is increasing from 0 to up to 100 milligram per liter, depends on the time durations. Also the another well is increasing up to 20 milligrams. Okay. So as we mentioned before, this zone is a highly intensively irrigated area where the irrigation is taking place more, the concentration of the solids, nitrate concentration is increasing. So in the 2040, so 2020, the concentration is drastic changes in the area. Okay. So this is the simulated solid concentration movement, how the concentration is moving towards the time periods. So it is moving from western part to eastern part. Gradually it's moving. Same like in the concentration. See the 2001, the concentration is less. Prolonged period when the duration is increases up to 2040, the concentration of the nitrate is very high. It's maximum of more than 100 milligram per liter. Also this concentration is extending to the other areas. So the high concentration is particularly we observed in the agricultural area. Same like the vertical and horizontal movement of the sodium chloride we considered. The sodium, this is nitrate concentration, how it is migrating through the vertical and horizontal movement. You can see here depends on the time periods. It's up to 14,000 days. It's moving in the dispersed in the other areas. Okay. So same like we try to, you can see here in this picture shows the agricultural area is predicted and calibrated. Its overall is matching with our groundwater modeling. Okay. So we predicted the sodium chloride also to understand how the seawater mixing is taking place in this area. You can see here the sodium chloride concentration is increasing above 7,000 milligram per liter. The another area is increasing up to the 120. Okay. So in the coastal area is moving, increasing the concentration up to 700 milligram per liters. Okay. So it shows the bottom portion of the study area, the other places lesser concentration. The drastic increase in the concentration were found in 2002 and 2010. It is clearly evidence of the lesser rainfall during these periods. Okay. So this is the predicted concentrations of the sodium chloride, how it is gradually moving towards throughout the times. Okay, in particular, it's moving towards the eastern directions following the groundwater flow. The groundwater flow also towards the eastern directions. So this is a spatial and temporal concentration of the sodium chloride. You can see the pictures during the 2040, how the concentration drastic increases around 8,000 milligram per liters. The another figure 3 and 4, the concentration increasing around 12,000 milligram per liter. That means it's a very high concentration. So the agricultural, there is no possibilities if the trend, if it is increasing in continuously. This is a vertical and horizontal movement. How the sodium chloride concentration, if it is moving, it's laterally, it's move 1.5 kilometers speeding based on the periods. So this is the predicted solid concentration of the sodium chloride in the 3 locations which you can see here. So it's observed the water quality data assigned the model. The concentration was predicted up to 2020. This is a clear idea how the concentration developing throughout the times. So finally, I would like to conclude this this research. So in this study is groundwater chemistry is influenced by the mineral weathering, reverse ion exchange, and irrigation rate and flow. So induced mineral weathering caused by the nitrification and wastewater infiltrations. The human health risk assessment result, it shows the infants are highly affected than the adult and children, in particularly due to the arsenic, cobalt, lead, and manganese. The groundwater is highly affected, the infiltration from the irrigation activities. So the positive relation between nitrate, EC, sulfate, it implies that the groundwater quality is affected by the surface contaminations, in particularly in the irrigation return flow through the fertilizers applications. Then the decline the groundwater potential map based on the AHP and the Boolean approach indicates 66% are good, 28% of poor, and 6% is very good recharge areas. So it shows that we try to advise to construction of the recharge structures in the rainfall in the high recharge area zones to control the groundwater quality and maintain for the long-term periods. So the solid movements indicates the possibility of migration of contaminant toward the eastern side. So this present study suggested for the detailed study need, in particularly in the related to seawater intrusion, also in the agricultural practices. So the groundwater modeling needs to be developed further. I think. Thank you so much.
Okay. Speaker, Professor Elumalai from South Africa. I think it's a very interesting presentation because if we talk about the water, because in our life we always need water. Okay, and maybe from the audience, from online and also from offline, I think there are a lot of questions. But maybe if you have any question, you can write on the chat box. And for the online audience, maybe you can ask directly when the Q&A session. Okay, thank you, Professor Elumalai. Maybe we can continue to the next speakers. We will continue to the Professor Aisha Abdul Jalil from UTM. Hello, Professor Aisha, can you hear me?
Wait. Yes.
Okay,
I can hear you.
Thank you.
Professor.
Thank you so much.
Okay, thank you, Professor.
Then the window. Hello? Can you hear
Hello.
me?
Yeah, it's clear.
Okay, I need.
Okay, Professor.
Thank you.
Before
Don't worry, my speech is not too long, so you can ask many questions later.
Okay, Professor.
Malay.
Yeah.
Okay.
Okay, before we continue the presentation, Professor, let me to introduce Professor Aisha Abdul Jalil. Okay, Professor Aisha Abdul Jalil come from Department of Chemical Engineering, Faculty of Chemical Engineering from UTM, University.
Why?
Also from Japan, and Bachelor Engineering from Japan. And the publication about what is it, materials and the catalyst, also photocatalyst. Maybe we can ask anything about the photocatalyst or about the energy, Professor. Okay, please, Professor Aisha Abdul Jalil, time is yours to presentation.
Okay, thank you very much, Aini, for the kind introduction. Okay, let's start. Uh, First of all, I would like to thank again to Universitas Pembangunan Nasional Veteran Jawa Timur for inviting me to this as a keynote speaker in this 7th International Seminar of Research Month, ISRM 2022. And not forget also, I would like to thanks again for inviting me as a in the program of World Cup professor. And so this is one of the contribution from that program. So I would like to share with you what I've read recently. It's not easy to find the title of this talk because the committee said you can choose whatever topic you want. So I I think this is the best topic to relate with my what I'm doing now. So let's go for the global energy transformation towards a more environmentally sustainable future. Okay, talking about the environmentally sustainable future, if Prof. Alumalai talk about the day zero for the water, so in energy there is a net zero CO2 emission by 2050. So this is the term which mean the goal of reducing greenhouse gases and CO2 emission to fight global warming. Okay, I think all of you know about this. I just pick up from the Google. There are three main routes to decarbonization, meaning net zero, meaning the CO2 emission is zero. So that means equal to decarbonization. Three main routes. One is the reducing demand for carbon intensive products and services. Okay, and then the second one is the improving energy efficiency. Okay, whatever related to energy efficiency, it has to be reduced to go for the objective of this net zero. And then the last one is deploying decarbonization technologies across all sectors, including electricity, biomass, carbon capture, and also the last one is hydrogen. Okay, so maybe we can we can contribute in these four main decarbonization technologies. Okay, and then when talking about the energy, this is I pick up from one report from International Energy Agency reported in 2011, quite old. This report. We can see from here that the world energy consumption is keep increasing in parallel with the world population. Okay, especially for the developing countries. Okay, for the modern countries, in the industrialized countries or developed countries, maybe is retained. Okay, in this like here, like shown here. But for us, okay, we need energy. Okay, this is the scenario for global energy trends towards
Excuse me,
2000.
Professor.
Yeah.
Sorry, the slide is not moved to the next. It's still in the first page. Yes.
What? what I have to do?
Maybe yeah.
Again and again, like that time. So what I have to do?
Maybe you can show slideshow.
This is slideshow. Stop. Then this is hide, and then slideshow. This is slideshow. You can see slideshow. Cannot.
It's never mind.
You can see now what is the what is the slide now?
Slide 4. It's right?
Slide 4. Is it global
Yeah.
energy trend to 2040?
Yeah.
Okay. So you can see this slide.
Yes.
Okay.
I can see
This
the
is
slide.
You can
you
make
can
it full screen. Sorry,
now is full screen. I can see
not
full screen. Is it
not
net
yet.
zero by 2050? I need
Yeah.
now is net zero
Oh,
by 2050.
2040. 40. Yeah. In the slide 4.
Oh, cannot
It
move.
should be what slide, Professor?
Now I'm moving the slide. This is number 4. This is number 3. You cannot see number 3.
Mm,
Cannot see the
4.
moving.
4. Yeah. This
Huh?
3. Yes.
Okay, you can
World
see.
population and energy demand growth.
Yeah, and then
Yeah.
when I slide show like this, and then go to the slide 4. Is it? You can see the slide 4?
Not yet.
Not yet. So I don't know what to do.
Yeah.
So maybe
Yes. Oh, it's
so
delay maybe, Professor.
for delay.
Yeah. It's never mind, Professor. Okay. Thank you,
Okay.
Professor.
Can I go with this one? With not slideshow.
It's enough. Maybe this is the 4th page,
Number 4.
right? Yes.
This is number 4. This is number
Yes.
3. Okay, you can see.
Okay.
Okay,
Yeah.
sorry.
Mm.
Okay, number
Thank you,
4.
Professor.
You can see number 4.
Yes.
Okay, number 4. Okay, this is about the global energy trends towards 2040. Okay, about the global primary energy demand growth by region. Okay, this also reported by IEA 2018. This is by the region. Okay, if we can see, the blue one is the Asia Pacific, and then the America, and then the Europe, and then the Middle East, and then the Africa, and also the international bunker. International bunker is referred to the energy used for the ship, aviation and ships. Okay. So what we can see, keep increasing from 2000, year 2000 until 2040, keep increasing. And the important one is, if we can see, for the America and also Europe. Okay, for America and also Europe here, America where? This is America. This is Europe. We can see almost zero. Aini, can you hear me?
Yes, I can hear you. It's very clear.
Okay, okay. Thank you. And then for the America and Europe, that maybe maintain or maintain. What I can say is maintain. But for the same for the international bunker, but for the our Asia Pacific and also Middle East, there is a decrease in the energy demand, slightly decreased, but still largest growth in the energy demand. So that's all for the energy demand, and then go for the next. This is for the global energy mix. Okay, the comparison of the global energy mix between 2010, year of 2010 and 2020. We can see that the most important one still fossil fuel. Okay, but decrease about 3%. Okay, and also same as nuclear, also decrease a little bit, but the renewables energy increase about 4%. Okay. Yeah, this is about the global energy mix in terms of renewable energy. Comparison of the contribution of various renewable energy, as we can see here. renewable energy sources in the global energy mix between 2010 to 2022. The green is 2010 and then the blue is 2022. What we can see still hydro, and then number 2 is wind, and then the solar play important role in this global energy mix. Okay. Okay, this is about the ratio. Then this is when we go for details. This is from IEA 2018. We can see the okay. Let's see from the first one. This is also the energy source. The renewable energy sources we see for the oil and coal. We can see almost zero. Okay. And then maintain up to it's predicted up to 2040. Then for the second one, for this natural gas, okay, we can see natural gas, and then also bioenergy. Yes, here bioenergy decrease, but decrease slowly. Okay, and then for the nuclear increase, you can see.
Excuse me,
And then
Professor.
for the, ya tak dengar. Ini tak
The
dengar.
slide,
No.
the slide just in the 4 page. Yeah.
Why? Can I stop?
Maybe can you share to us? Maybe we can help to share the presentation.
Okay, wait.
Okay.
Share to Adi, right?
Yeah, that's right.
Where is Adi? Wait, Sorry.
Never mind, Professor.
Okay, send to Adi.
Okay, Professor, we have received. Okay, we will try to show the slide.
Sorry.
Never mind, Professor. Maybe we would like to remember again for the audience, if you have any question, you can ask by write your question on the chat box, or for the offline audience, you can ask directly for the our keynote speakers. Professor, how about the condition in Malaysia, in the UTM?
Okay. I just came back from ITB, UE, and UGM last week.
Oh.
Looking for collaboration like I did for the EPS and UPN.
Oh, yeah.
I find out now Indonesia is very rich. Many 7 to 8 floors of building is going on now. It's too rich.
Yes, Professor.
Sorry. Okay, this is the first. Okay, please next. Go for next. Okay, then, but I cannot see. How to see? How to
Can
see?
you see the slide?
I will open from my computer also. Okay, this is the number 4. Number 4, right? Number 4. Okay. Number 4 I've explained, and then go to the number 5 also explain. Please number 5, and then okay, number 5. Number 5 is about the fossil fuel. You can see the decrease just a little bit, 3%. But in one day, I think same like Prof. Almar said, day zero. So maybe in terms of energy also, fossil fuel will keep depleting. In one day will be zero also. So that's why we have to move to the renewable energy. Like we can see in 2020, the renewable energy become 12% or 8%. And next, please. Next slide, please. Okay, this is the contribution of various renewable energy sources. Okay, we can see the main one is the hydro, and then wind, and then solar for the renewable energy. Others is from biofuel, and also others maybe from geothermal, from hydrogen maybe. Then next. Okay, this is the details contribution. Contribution from the renewable energy sources. Like I said, that we can see oil and the gray color and the black color keep decreasing, while the pink color and the yellow for the natural gas and also bioenergy keep increasing. Even if we see for the value maybe decrease, but keep increasing until 2040. And then for the most important one is the orange, the other renewable energy, and also the hydro keep increasing until 2040. This is the prediction. Okay, next slide, please. Okay, this is the summary. Okay, I can say this is a summary reported by IEA in 2020. This is you can see the non-renewable moved to the renewable from 2001 to 2020. Okay, we can see the green one keep increasing until 82% in 2020. Okay, the global power capacity addition by energy type. Okay, and then next, please. Why they are moving from the non-renewable to the renewable? Because maybe this transition can be attributed to the past. What is past? The political, economic, social, and also technology. Okay, which mean support policies driven by greenhouse gases. Next slide number 9, please. Okay. This transition because of the past, which mean the support policies driven by the greenhouse gases reduction goals, and then increasing availability of debt and money matters. Money matters become improved, and then mounting public opposition to coal and nuclear power generation. Okay, they are decrease on that side, and then rapid decrease in the cost of renewable energy technologies such as solar and wind. So that's why we can see the moving from the non-renewable energy to the renewable energy scenario. Okay, next, please. Okay, this is the evolution of global renewable energy generation capacity which in summary, the renewable energy share about 36.6%, including hydro in global operation capacity. This is in gigawatt. If you can see the hydro, no, the top one, the largest one become the solar, about 610 gigawatt until 2020. And then number two is wind, 466 gigawatt, and then number three is hydro. Okay, this is the renewable energy, and then come to the bioenergy and also geothermal. The next. Okay, this is just an example for the USA, America primary energy consumption by energy source. In 2020, reported just this year, April this year, reported by monthly energy review. You can see at the bottom. Okay, in US, they are used mostly in petroleum and natural gas. And then the renewable energy become the number three. Okay, about 12%, which come from the major from the wind, and then the hydroelectric, and then also from the biomass, and also from solar, and a little bit from the geothermal. Okay, and then nuclear electric power, and also from coal. Okay, that's the distribution of the energy consumption by energy source in US. Okay, next please. Next slide please. Okay, this is no, the previous one. Number 12. Okay, this is number 12. This is US energy consumption by major source. We can see from the year of 1776 up to last year, up to 2021. We can see the first one is the purple in color, the wood become decrease, then the coal increase, then now the petroleum and also the hydroelectric become the major one, and you can see the other renewable energy become increase also for the 2021. Okay, and then the other renewable come from the biofuel, geothermal, solar and wind. Okay, next please. Okay, this is the evolution. That is from US. Now is from Germany. Okay, the evolution of installed capacity by fuel in Germany. If you can see, okay, this is from 2002 2018. Okay, we can see the blue one at the bottom is about the nuclear power, and then the lignite, and then the hard coal, and then also natural gas, also mineral oil. Okay, now is, I can say that now is maintained a little bit decrease in 2010, and then maintain until now. And then the solar, the wind, and also the biomass and hydro power is keep increasing until now, the green color. Then the top one is the hydro power. Okay, this is the scenario in Germany for the renewable energy, with the use of renewable energy. Next, please. Then I pick up also, next please. I pick up also from the net generation capacity addition by fuel in India. Okay, we can see in 2011 until 2017. This is reported by EA at 2020. You can see the coal become increase, and then you can see in 2016 keep decrease drastically. Uh, in 2017, the use of coal. Then the use of the solar is increased, the yellow one. That is the energy transformation in India. Okay, next please. Okay, now in Southeast Asia, okay, from 2000 to 2020, last 2 years before the pandemic. Okay, we can see if we compare the renewable energy installed capacity increase, okay, more than triple from 2000 to 2020. From if you can see from 20 to about 86, 87% percent. Okay, so most of them is still hydro, the top one, then the solar, that's at number 2, then the bioenergy, then the wind, and then the geothermal also. Okay, next. Okay, this is the scenario in Malaysia, cumulative renewable energy capacity for Malaysia. Okay, the last one still hydro. The top one still hydro, and then become the solar, same with Southeast Asia scenario. And then the next one is biomass, and then the hydro, small hydro, and the biogas. The next please. Okay, if we review an overview of the renewable energy target in major ASEAN countries, we can see the from the left, we can see for Malaysia. Malaysia, the latest renewable energy policy is MyRER, meaning Malaysia Renewable Energy Roadmap. Okay, in 2035, we are targeting for 40%. Okay, the use of renewable energy. And then for the Indonesia National Energy Roadmap, latest RE policy in 2017. By 2050, Indonesia aiming for the 31% national primary energy supply. And then for the Philippines, by 2040, it's about 20 gigawatt. Okay. And then for the Thailand, about 2037, you can see about 33%. And then Vietnam, quite energetic. Okay, Vietnam in 2040 aiming for the 45%. Okay, and then for the Singapore, of course, Singapore 2 gigawatt by 2020 and 200 by 2025. So overall, I can say that similar aim or targets for all ASEAN countries. Okay, and then next, please. Come back to my first slide. Next, please. Okay, this is my first slide. Why I show this again? Because I want to relate the hydrogen with my study. Okay. If you can see, hydrogen is one of the important one, play important role in this net zero by 2050. Next, please. Why we need hydrogen? Because everyone knows hydrogen is a zero emission. Okay, we can produce hydrogen by many routes. Okay, for example, by gasification, by reforming, dry reforming of methane, then bioconversion also, pyrolysis. gasification, bioconversion also, and then ocean thermal energy from the ocean. Then also the last one is from water splitting. Okay, so hydrogen has many can be used for many applications. Okay, for the petrochemical, fertilizers, for heating, for especially for hydrogen vehicle, and also for formation of synthetic fuel, and also for power generation, and also, that's why we need to move to the hydrogen. All over the world now is talking about the hydrogen. It's not easy for us maybe, but we have to start. Okay, next please. Okay, this is the what I get from Google. Okay, now we have about two, four, six, nine colors of hydrogen right now. Okay, first one, the old one is brown or black. Okay, where we can get the hydrogen from the coal. Okay, from the steam reforming or gasification. And then we move to the what the next one is the gray. Okay, gray and blue from the natural gas. The process to get the hydrogen, what we call it steam reforming. Okay, the gray is we got the CO2 from the release one, but the blue we get the CO2 from the captured one. Okay, we capture the CO2 and then go for the reaction for the steam reforming. Then we go for the pyrolysis also. Okay, the turquoise one, hydrogen plus carbon, solid carbon from the natural gas, still natural gas. Then we go for the red and purple or pink. Okay, nuclear power plant from nuclear power. Okay, the red one is all the bottom four is for the water splitting. Okay, the water splitting when we use the nuclear power for the in the catalytic splitting process, we call it as the red. And then for the purple electrolysis, from nuclear power, we go for the purple or pink. And then for the green and also yellow, this is electrolysis. What we use is power, solar power, and also the renewable electricity. Okay, and then the last one is the white one. The white we can why we call the white hydrogen, because we get the hydrogen from the air. Okay, that's the colors of hydrogen. What they are talking about right now. Okay, hydrogen. Next slide, please. Okay, hydrogen is a cleaner fuel. Okay, actually hydrogen is a energy carrier. Okay, reported by Zapantis in 2021. This is a breakdown of global hydrogen production in the world by source in 2019. Okay, we can see the most largest one is from the methane of coal. And the product is the syngas, CO plus hydrogen. And then also from the methane, we can get from number two, we can get from the methane to produce pure hydrogen. Then number three is pure hydrogen from coal. And then next is the electrolysis from water. And then also methane of coal that produce syngas with CCS, meaning carbon capture and storage, the storage one. And then the methane flow also from the CCS. From CCS, we can produce the pure hydrogen. Okay, next, please. This is just a summary the production of hydrogen. Clean hydrogen production. We can get the hydrogen from the electrolysis, PV electrolysis, meaning we use the solar. Okay. And then thermochemical, okay, electrochemical also, and then photo electrochemical. We use photo, we use electric to produce the to split the water to produce hydrogen, and then biomass gasification and also solar thermal. Next, please. This is the global hydrogen demand. Why they need hydrogen? If you can see from 2020 at the bottom to 2030, the demand keep increasing for the hydrogen, especially in the industry. Okay, for the purpose of the industry. Next, for the green injection. Okay, and then also for the refining. And then the yellow one for the power. This is in megaton. Reported by EA. Then for the ammonia also, production of ammonia, also for the synthesis fuel, and also for the buildings. Next, please. Okay, I just pick up some examples. Next, please. This is the I think all of you know about this Toyota Mirai. What is Mirai? Mirai in Japanese means future. Okay, this is Japan fuel cell vehicle. Okay, hydrogen car. Where we can say hydrogen car, which started the research from 1992. If you can see the biography. 1992, Toyota starts develop the FCV technology, fuel cell vehicle technology. Then in 2010, okay, they already successfully commercialized the bus, okay, bus from fuel cell bus, okay, in Tokyo from Haneda Airport to the city center, 2010. And then 2013, Toyota shows FCV, their FCV at Tokyo Motor Show. Okay, you can see how many years. Okay, and then November 2014, they launched the Toyota Mirai. Okay, and then 1 year later, they start to sell in US. And then 2018 in Australia. Okay, commercialized. And then 2019, okay, they come up with the second generation with the improvement of the first one. This is the if we can see from 1992 up to 2019, about 27 years, about 30 years, they come up with this Toyota Mirai. Okay, next please. This is some of the an example for the use of hydrogen or hydrogen car. Then this is the world's first hydrogen train. Okay, what they call Coradia Island. This is if you can say okay that's they start in France. They start in France in 2021, 6 September. Okay, and then already in service in Germany. Okay, they are used in Germany. This is the first largest one. You can see, Island can travel 1,000 kilometers on one full hydrogen tank and can reach a maximum speed up to 140 kilometer per hour. Okay. Next, please. This is hydrogen train, and then next, please. The Japan also go for the hydrogen power train. Okay, which will be commercialized in 2030. Next 2030 by the JR JR East and Japan Railway East, developed by the Toyota and also the Hitachi. Okay, but this is a little bit slower than the French one. Okay, French is 147. This is 100 kilometers per hour, but they are already in pipeline for the hydrogen train. Next, please. Then I pick up also some energy projects. Uh, some energy projects in MENA. MENA mean Middle East and North Africa region. Okay. I pick up the most largest the important countries that use the energy renewable energy, okay, especially for solar. There are, the first one is UAE, okay, United Arab Emirates. You can see what the project names is Al Dafra Solar Project, okay, 2 gigawatt project. Companies involved, okay, you can see Chinese always collaborate, always join with Middle East company, okay, with Abu Dhabi, and then they can reduce the CO2 up more than 2.5 megaton per year, okay. And then next is Nur Energy project, 950 megawatt. Okay, this is the world largest single site solar energy plant in UAE. Okay, also the local with the Shanghai Electric. Okay, and then there's Saudi Arabia, Sudair solar plant, about 1.5 gigawatt. Okay, also world largest single contracted solar PV plant. And then Morocco, Nur 123, okay, they have 123 plant. The UAE, the first one is Nur 1, okay. Now Morocco 123, all the 3 power plant is about 500 megawatt. Also, world largest PSP plant project, concentrated solar power. And then the Oman also, project Mana 1 and 2, 1 gigawatt. Expected begin to be commercialized in 2024 soon. Okay, this is reported by the Razi et al. And Ibrahim Dinser. Okay, in 2000 this year 2022 in RS Renewable Sustainable Energy Reviews paper. Okay, next. This is all is about net zero emission by 2050. The aim for that. Next, please. And this is for the renewable hydrogen projects in also MENA countries. Okay, in Morocco, they targeted 2025. Okay, 300 to 500 megawatt green hydrogen and ammonia also. Usually ammonia maybe for the production of ammonia, and ammonia also can use as a as a carrier, okay, for the hydrogen. Okay, they convert to the ammonia form. And then 2024, the companies involved is Masin, okay, 100 megawatt, only green hydrogen. And then it's Saudi Arabia, 2025, Aramco, the big company, okay, about 4,000 megawatt, okay, electrolyzer capacity. They aim for that one. And then also green hydrogen shipped as ammonia. And then the Egypt, the agreement already signed, okay, in 2000 last year. And then 50 to 100 megawatt green hydrogen and also ammonia. And then the Oman, okay, 100 million tons ammonia per year, okay, green hydrogen and ammonia. So we can see in MENA already ongoing all big projects for the hydrogen. Next, please. This company. Next, please. Okay, but still they have a challenge for deployment of renewable and hydrogen energy. This same maybe with us. Some of them what the facing in Luna. Some of the challenge is domestic pricing mechanism of fossil fuel. Okay, then high cost of green hydrogen production, then inadequate hydrogen transportation infrastructure because still new. Okay, then lack of awareness towards significance of clean energy utilization, then lack of economic incentive for the RE utilization. Okay, again same first. The electricity pricing in the region. Okay, so that's among the challenge that we have to think about. Then next, okay, come to the end. Next slide, please. Come to the end. I would like to introduce one of our research institute in my university, in UTM, University Technology Malaysia. We have many research centers. We have many research institute. We have many research groups. Okay, one of them is what we call it Institute of Future Energy. Okay, the director is Professor Dr. Asha Ahmad. And then under this institute, we have 3 centers research, COE, what we call it Center of Excellence. One is Center of Hydrogen, led by me. And then my friend, Center of Electrical Energy System, led by Dr. Fauzi. And then Ocean Thermal Energy Center, led by Dr. Satya. Okay, all of us just came back from UE, University Indonesia, and then ITB, and then also UGM. Okay, last week, looking for collaboration, especially for the all about energy. Okay, next slide, please. Next slide, please. Okay, and this is the what we have in our CHE, Center of Hydrogen Energy, what we have now. Okay, from the bottom, we are we doing from the 1, 2, 3, 4, 5. We doing all is about the hydrogen. We are doing from the production, storage, utilization, safety, and also simulation. Okay, but maybe for the for example, for the production, photoelectrochemical PEC, water splitting, and then dry reforming of methane, gasification, bioconversion. We are doing all, but still in the if you're looking for the TRL, still 1 to 3 or 1 to 4, still in the lab scale. Okay, and then for the storage also same. We are doing for the pressurized hydrogen storage, absorption storage for the hydrogen. And then we are going to also for the LOIC, liquid organic hydrogen carrier. Okay, we are looking for that one. We will start soon. And then for the utilization, this may be for the utilization for fuel cell, SORC, catalysis sensor battery, especially for the fuel cell. Maybe I can say that already achieved for the TRL 7 and 8, okay, 89, because we have the hydrogen motorcycle, hydrogen motorcycle wheelchair also. Okay, then for the safety, we have expert. Okay, many expert safety, hydrogen safety. Okay, piping, explosion, risk assessment, energy management. We have expert, and also we are expert in simulation and also modeling for all processes. So we are looking forward for a collaboration from your university. I know now Indonesia is very richer than us. Okay, I can see the drastic changes from your lab. Okay, all of your lab, your facilities. Okay, I hope we can do something to collaborate. Okay, for the lab scale, maybe you can test in Malaysia and then go back to the Indonesia. You can go for the pilot plan. Okay, Next, please. Yeah, I just share 2 slides about what I'm doing now. This is example, okay? What I pick up from one of our papers from chemical engineering science, published in 2021. This is about the dry reforming of methane to produce hydrogen. If you can see at the bottom, methane plus CO2 produce syngas, okay? CO and hydrogen. This is the lab scale. We use the successful story. We use the nickel fibrous ZSM5. If you can see the shape of the catalyst is right rambutan. Okay, the core is the nickel, and then the outside covered by the silica fibrous, very high surface area, and then very has a very an appropriate basicity for this DRM reaction. Then if you can see the graph, the A graph, you can see almost the CH4 conversion and also CO2 conversion almost more up to 90%. Okay, we can achieve that one with the H2 to CO ratio is about near to 1. I can say near to 1 is a good catalyst. This is just one example. We have many catalysts. We just change the core with any metals. Okay, outside is fibrous, so we can reduce the basicity. We can up the surface area. Then you can apply for many application. Okay, this kind of fibrous catalyst. Then next, please. Next example. Next slide, please. Next slide, please. Okay, this is another example for the fibers silica alumina. Okay, we just change the nickel with the alumina, and then also we got good result, and we published in IGHT recently, International Journal of Hydrogen Energy. The previous one, when we synthesize after we synthesize the nickel on fiber ZSM5, we load with the tantalum. This one just nickel and fiber silica alumina. Okay, next, please. That's all from me for this for today. Okay. So what I can say, a journey of 1,000 miles begins with a single step. So we have to start. Let's collaborate for our sustainable future. Mean gambaro, okay, in Japanese. Mean let's go. Okay, that's all from me. I'm looking for collaboration from all of you. Okay, Aini, that's all.
Thank you, Professor Aisyah. Please give applause for Professor Aisyah. Thank you very much, Professor. Okay, Professor, there are a lot of questions from the audience. Maybe we will read one by one, and then maybe we can to ask for the offline audience. Maybe any question from offline? Okay, we try to some question from the offline audience. Okay, Prof. Yes. Okay, the first question from Miss Rahma.
Oh, Rahma.
Yeah.
Assalamualaikum warahmatullahi wabarakatuh. Thank you so much for joining us today to Professor Dr. Vetri Murugan Elumalai and also Professor Aisyah Abdul Jalil from Malaysia. I have some question, but before that, let me introduce myself. My name is Rahmawati. and I'm from Faculty of Engineering, especially from the Food Technology Department. So in this occasion, I might be not have sufficient background in terms of environmental and also the global energy background. But I was wondering about some of insight that you have presented during your presentation. So for Professor Dr. Vetri Murugan, I have two questions for you. The first question is about the contamination rate in the Cape Town as you presented on your presentation. So my question is that what is the main contaminant near the body water of the Cape Town that can affect the health risk assessment that you have presented previously? And the second one, what would be the main aspect that could influence to minimize this contamination in the body of the water? And for Professor Dr. Aisyah Abdul, I have questions. The first one is about you mentioned that the global rise of hydrogen is increasing. So, what would be the impact to the sustainability of these hydrogen sources? Would be cause the scarcity for the hydrogen itself, or can the hydrogen be renewed for the next decades or not? And the question is that about a let me see the notes about the hydrogen. Is the hydrogen can be used for the food industry, or it can be only to power the train and something like that, or can this be also used for the food industry to power the all the electricity, all the machines in the food industry? Is this possible to be used in the food industry? That's it. That's my question. Thank you so much, and I would like to give this to moderator. Thank you.
Okay, thank you, Mrs. Rahma, for the question. Maybe for Professor Elumalai and Professor Aisyah Jalil, maybe you can answer the question from from Mrs. Rahma. Okay, time is yours. Maybe from Professor Aisyah Abdul Jalil or from the Professor Elumalai will respond the question from Ms.
I'm so sorry, Aini. I cannot hear the first question for the hydrogen.
Okay. Maybe Mrs. Rahma can repeat
The
the question.
second one, I can answer the second one about the food. Can the hydrogen can be used in the food sector, right? What I can answer now, I have to study. I do not have that kind of knowledge now for the food industry. But if you are talking for the electricity or the energy that will be used for the food industry, of course, I think, no, not I think, of course, hydrogen can be convert to the electricity for the to apply for the food industry. But am I answer your question? But for the food itself, meaning I think what I imagine now is about the chemical reaction occur in for the food industry when we react the hydrogen. Is it the meaning of your question? Aini, can you hear me?
Yeah, I can hear you. Okay. For the first question.
The first question, what is the first question?
The first question, what would be the impact on the global rise in hydrogen demand? Can you hear me?
Okay, rise is RIS. What will be
the impact on the global rise in hydrogen demand?
Looking for the scenario, what I've picked up from the literature. the hydrogen demand keep increasing all over the world. When in Malaysia also, they are always talking about hydrogen. We can see in the developed countries, they have been they have applied all, for example, for the car, for the vehicles. Okay, they are using the hydrogen. So yes, the hydrogen demand will be keep increasing. Am
Okay.
I answering the question?
Yes. Okay. Thank you, Professor Aisyah. Maybe we continue to Professor Elumalai. Hello, Professor. Can you hear me? Professor Elumalai?
We cannot. Oh, we can see the participant. Maybe not already left.
Okay. While we wait for the Professor Elumalai, maybe we can continue to the next question. Oh, Professor Elumalai, hello.
There. You are mute, from
Maybe you
Almala.
can, yeah, you can
You are
unmute
mute.
your microphone and then you can open your camera. Okay, while we wait for the Professor Elumalai, maybe we continue to the next question. This is the next question from Laksmi Diana from the online participants. The question is, how will today's energy crisis in Europe give impact to ASEAN countries' industry?
It's very
This is the
difficult.
question for Professor Aisyah Abdul Jalil.
Very difficult to answer. How would today's energy crisis in Europe give impact to ASEAN countries' industries? I cannot answer this question. Sorry. I still new in this energy transformation. Sorry, Lakshmi, Diana. Sorry, Aini.
Yeah. Okay, Professor. Maybe we have to more literature study maybe to
Yes.
answer this question. Okay. Thank you, Professor Aisyah. Maybe any question? Maybe we will to great Professor Elumalai. Can you hear me? Professor Elumalai? Okay. Professor Aisyah, there is a
Yes.
question again. There is a question again. This is from the online. You say the presentation that the hydrogen is a zero emission. How about the efficiency from hydrogen-based fuel compare with the coal-based fuel? Maybe from the price and other. Okay,
From
the
the
efficiency.
price, maybe
Yes.
the price. I forgot to show the graph. The become less. Okay, become cheaper. The hydrogen. I believe one day it can compete with the when we use many hydrogen. I believe it can comparable with the both in price and also in the efficiency. We can comparable with the coal. Okay, the previous one. But now maybe still expensive, but getting cheaper. And then we can maybe the important one, they are targeting for the net zero. Okay, for the environmental our environment.
Okay, so the hydrogen fuel is one of the renewable energy that we can imply in our life. Like,
Yes.
right? Okay. Maybe any question again from the offline attendance? Any question? Okay.
Okay, what I can say from my study about the PEC, photo electrochemical water splitting. Maybe the efficiency is still low, about it's not easy. It's still lower than 30%. Okay, what I know right now, the efficiency is not easy to get the hydrogen from the water. Okay, but we thinking about we got the PEC, we can get direct from the solar and also the water. Okay, the free solar and the water. Even the still less than 30% the efficiency to get the hydrogen, but it's still cheaper, eh, compared to the other sources. So what I can say right now, I believe one day the PEC will be the efficient one. Okay, method to get the hydrogen. That's from my study. Aini, is it okay?
Yeah, it's okay.
Okay.
Okay, thank you, Professor. Maybe any question again? Professor Elumale, maybe can you hear me again? Maybe you
What is
are
the
still...
question for the
Yeah.
Professor Alumni?
Okay, there are a lot of questions for Professor Elumale, but maybe Professor Elumale not stay in the stage, in the location, and maybe we continue to the next question. Maybe any question again for Professor Aisa Abdul Jalil?
I saw the photos from slide of Professor Alumalai. Is it signing the MOU or MOA between the UPN and the Professor Alumalai Universities? Ini
Yeah.
I saw the photos. The background about signing. Is it for the signing MOU something like MOA? Okay, I see.
Okay. For the signing is maybe we will ask with the committee again, Professor, for the
Okay.
next. Yes, for the next detail. Okay. Thank you, Professor. Maybe any question again for our keynote speakers? Okay, Professor Aisha Abdul Jalil, maybe if we look from the presentation, we can know that the hydrogen have any change, but maybe we can to develop in Indonesia, maybe, Prof.
Of course.
Yeah. I think
Of
if
course.
we do this research just in one university, maybe we can to develop in the big result. Yes. So we have
Yes.
to maybe collaborate with the other university for develop this hydrogen fuel.
Okay. Yes, yes.
Okay.
We are
Okay,
looking
maybe
for
if
the
there is...
Ini.
Yeah.
We are
Okay,
looking
Professor.
we are looking for the collaboration with the UPN. Okay.
Okay. With me, Professor. Okay, thank you, Professor. Thank you for your welcome.
Okay.
Okay, thank you very much for the all of the audience and for the online audience, also for the offline audience, and also thank you for Professor Aisa and Professor Elumalai. Maybe before we close the session, we take a picture for Professor Aisha and Professor Elumalai. Maybe we'll open the camera, and then all of the participants offline can stand up in front of the stage. Maybe we can to take a picture together. Okay. Maybe for the offline audience.
I need how many participants I can see clearly.
Oh, maybe around 100.
100, too many.
Yes.
Okay.
But for the parallel session, there are 300 participants maybe.
Wow. Okay. Offline and online.
Yeah, this is hybrid. Okay, Professor.
Subhanallah.
Maybe for the all of the participants can take the place in front of the stage to take a picture together.
May I know what is the meaning of the month? Research month meaning what?
Research month. Yes, this is annual meeting, Professor.
Annual
Annual.
meeting.
Yeah.
Okay. Okay. For all faculties?
Yes, for all faculties in UPN, Veteran Jawa Timur.
Okay. And also from other universities?
Yeah.
Oh, okay. I see. Good, good. I can see.
Please, maybe all of offline participants can take place in front of the stage and we will take the picture together. Maybe Prof. Aisyah can open the camera and we can take the picture together. The committee will give the instruction for the take picture.
Back picture? Wow. Ada bunga.
Okay, I will give instruction. 1, 2. Okay. 1, 2, 3. Okay, once again. 1, 2, 3. Okay, maybe freestyle. 1, 1, 2, 3. Okay, bela negara.
Oh, bela negara.
Okay. Prof Aisyah, maybe you can bela negara. Do you remember?
I don't know. I forgot the sign.
Okay, 1, 2, 3. Okay, thank you very much.
Thank you.
Okay, thank you very much, Professor. Okay, I'm so sorry if I have any mistakes when I moderate the session. Thank you very much. See you, Professor Aisyah.
Waiting for you to come to Malaysia, I think.
Okay, yeah.
Okay, bye-bye.
Waiting, Professor. Okay, bye. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Professor Aisyah Jalil. And thank you for the audience, offline audience, and also the online audience. I'm so sorry if I have any question when I moderate this session, and maybe see you again in the next agenda. And please, I will back to the MC. Thank you very much.
All right, such a nice discussion that we just had.
Okay, ladies and gentlemen, that was so many insight that we gained during the main session, not only for the expertise in the global energy, but also for the environmental issue. Hopefully, after this, we can gain so many ideas to expand our research and also the collaborations in between the field of expertise. So, Mr. Aryo, what would be our next agenda?
Okay, for our next agenda, we will be having the panel session. So, invite everyone who are going to present their papers, their findings in research or in social services. Please stand by And after this, we'll be having a short break for 1 hour. So for those of you who are going to present, please watch for your schedule that will be displayed in front of the screen, or you can go outside and just check your schedule just outside of the room.
Okay. In addition, for the schedule, it also has been posted in WhatsApp group, so you can also access in our WhatsApp group. And if you have any question, you can summon one of our committee in the WhatsApp group. Okay, this is the end of our session for today. So enjoy for the break and as well as the parallel session. See you and good afternoon.
Thank you.
Thank you.